This is section 1, graphical approach to limits, example 5. So along with finding the limit as x approaches a number, like in the middle somewhere potentially, we also want to see what's happening to the right and to the left. And you might remember this when you're talking about rational functions and whatnot as end behavior. And we're going to talk a lot about end behavior when we're talking about limits and x approaching infinity. Okay, so remember that infinity, positive infinity, is always going to the right. Negative infinity is always going to the left. Now keep in mind, if I'm going to the right, I can only approach the right from the left. Okay, so you're not going to see in the notation anything where it's like x approaches infinity from the left. From the left. It's implied. Okay, you're also never going to see x approaching infinity from the right because it's not possible. Okay, remember you're going to the right forever. Now this is the notation, x approaches infinity. Okay, so let's go ahead and answer these questions. There are 5 possibilities. Okay, it can go up forever. That's the first one. So as we approach negative infinity, remember when we're finding the limit, we're finding the y value. Okay, it's the y value. So because even though we're going to the left, the y value is going up in this graph. So up. That's to the left. I'm just following the graph and it goes up. So because it goes up to infinity. When I go to the right, when I go to positive infinity, hey, look, that's also going up. So because that's also going up, that's also going to positive infinity. Remember, your output is the y value. And if it goes up forever, that's what you're putting. Okay, even if it's to the left. Let's look at B. The curve can go down forever also. So if we go to the left on this one, right? So the limit as x approaches negative infinity. That's to the left. It is going up. So you can have up infinity as your answer. All right, as we go to the right, see how it goes down? It's going to keep going down forever and ever and ever. So because of that, it's going to negative infinity, right? Because again, it's a y value. We can also have a number, an asymptote, a horizontal asymptote. And keep in mind, please, you can cross a horizontal asymptote. You are allowed to. You cannot cross a vertical asymptote. That's not allowed because that's actually literally undefined. But a horizontal asymptote is a guideline. Okay? And you can have multiple horizontal asymptotes. You can have 0, 1, or 2. Ever. Okay? In a function. So keep that in mind. Now, as we go to the left, so towards negative infinity, we follow, and it gets closer and closer and closer to the number 4. So even though it's an asymptote, we might not touch it, we're going to say it's getting toward 4, and so the answer will be 4. For the limit as x approaches positive infinity, we're going to the right, and you can see that goes down to negative 2. But again, we might touch it, we might not. As long as it's getting closer and closer and closer to number, it's kind of trending that way, then that's the answer. So that's negative 2. Another thing that can happen in example D is it can get closer to a value with oscillation. Okay, and you should know what that word is, right? Because we all took pre-cal. Oscillation is when it goes up and down and up and down and up and down. Now, something like sine and cosine, that goes up and down the same distance forever. But if you look at example D, you can see as you go to the left, it's going down and then not as high, and then not as low, and then not as high. So we can assume it's going to taper out and go toward a number. And that number that it's surrounding, that is the limit. Okay, as x approaches negative infinity, which ends up being 1. From the right, towards the right, not from the right, towards infinity, we're doing the exact same thing. It's just centered at 0. Okay, because it goes down, not so far as it went up, right? And then a little bit up, and then a little less down, and then a little less up, and then tapers off. Oh no, I missed one. E. The curve can oscillate but not get closer to a value. So that's that sine and cosine function, right? And the left side is an example of something, of one of those functions stretched out. So it goes down the same as it goes up, right? There's no trend there. And because there's no trend there, it doesn't exist. Okay, it's just going to keep oscillating the same way, at least as far as we're aware. You could always argue maybe something different, but as far as what we can see, that's what we're given. Okay, and then to the right, it goes down and up and down and up. And you can see it's oscillating, but it's not oscillating around a particular number. It's actually just going up forever. And so that's why that's going to be infinity, because it's going up. And those are the possibilities for the limit as x approaches infinity.